Really, I just cleared it out. Oh. Hopefully it'll keep recording. All right. Okay, so we'll let y equals Lewis's rate of speed. Okay. So we know they both walk 2 hours, which means that the time we know what it is. It's t. I mean, 2. Okay. So since they walked for 2 hours, t equals 2. Okay. So we know also that the distance that Alfred walked, remember distance is equal to rate times time, our rate for Alfred is 2 times, well, r is 2, 2 times t. Nope, 2 times x, rather. Oh, sure. Okay, so remember, that's our RT. Since we know his time is 2 and our rate of speed is x for Alfred, it's R and T. Plus the rate of speed that Lewis walked is 2 times y. Remember, that's our time is 2, and the rate that Lewis has walked is y. Okay, is equal to 15. So we have the distance that Alfred walked and the distance that Lewis walked all add together to equal 15. We just changed the distance to equal their rate times time, which we only know the time. We have to figure out the rate. Okay, so we have 2x plus 2y equals 15. Okay, that really doesn't help us a lot. So if we look back at our problem, what else do we know about their rate? Yep, Lewis walked 1 mile per hour faster. So since Lewis walked 1 mile per hour faster, that means that if, what's his name, Alfred walked x miles per hour, then Lewis walked x plus 1 miles per hour. So that's our second equation. Y equals x plus 1. Does that make sense? All right. Oh, no. Nope, which one did I have? Make sure I didn't mix up the names.
No, Lewis.
Yep, Lewis was 1 mile per hour faster. Yep. Oh, I have been known to mix them up, so if it doesn't look right, definitely say something. All right, so. All right, so this is Lewis's rate. So now we have our 2 equations. So the easiest way is just use substitution, plug it right on in, and solve for x. Oh, make sure I push that up a little bit. Using substitution, we have 2x plus, instead of 2y, we'll have 2 times x plus 1 equals 15. Okay. So now all we have to do is just get rid of our parentheses, solve for x, and then plug that back in to solve for y. Okay, so we can get rid of our parentheses by distributing. So that means we have 2x plus 2 times x plus 2 times 1, which is just 2, equals 15. Okay, so we can combine these two to just one term. So 2x plus 2x is 4x. Plus 2 equals 15. Okay, so if we subtract 2 from both sides, and we'll continue that one right over here, that disappears, so we have 4x equals 15 minus 2, which is 13. Okay, so if we divide both sides by 4, we have x equals 13 divided by 4, which we can actually convert that to a mixed number. And I'll do that kind of on the side here, so I won't take up too much space. Okay, so remember 13 divided by 4, move that over, is equal to, you can convert that to 13 divided by 4. 4 goes into 13 3 times. 4 times 3 is 12. 1, so you have 3 and 1/4. Okay, so we know Alfred walked 3 1/4 miles per hour. Okay, so since we know Alfred walked 3 1/4 miles. Since Lewis walked 1 mile per hour faster, we just add 1 to what we know Alfred walked. Okay, so let me block that off. So since y is equal to x plus 1, that means that y is equal to 3 1/4 plus 1. See, I take all this room up here for granted, then when I get down here, I have to try and squeeze it. See, all this space I wasted. Okay, so y is equal to, actually it'll be easier to make that 13/4. Oh, sure. Sorry about that. It'll be easier to make this 13/4 plus 4/4. 13/4 plus 4/4, which is 17/4. And using the same division method there, it's 4 1/4. Could have did that in my head. I don't know why I worked all that out. But that's how you would work it out. Okay, so we know that this is, bless you, Alfred's rate, and this is Lewis's rate. Oh, make sure I'm not blocking. Okay, it's kind of drawn out and tedious, but we eventually got there. Any questions on that one? All right. Let me pick another one to kind of. That's a pretty good one. All right. Okay. Now this one is a mixture problem. So, but we're going to use the same approach. Okay, so what if we have a chemist needs 10 liters of 20% saline solution. Just a fancy way to say salt water. Okay, but unfortunately, they only have 5% and 25% mixtures available. Okay, so how much of each solution would he have to mix together in order to get 10 liters of 20% saline? produce a 20% saline solution. Okay, so we know we're trying to figure out how much of the first solution, how much of the second solution would give us a 10 liters of 20% solution. Okay, so we start off with our solution here. Okay, so we know we want it. Well, we want to know how many. What is it? 5% solution. I guess you could say number of 5% solution would probably be a little bit better. Number of liters of 5% solution plus the number of liters of 25% solution is equal to 10 liters of 20% solution. Okay, so we have a certain number of liters of this percent plus a certain number of liters of the next percent equals the amount that we're looking for. Okay, so believe it or not, this will actually all work out. Move that up a little bit. Here we go. Okay, now this, make sure this is down far enough. If we wanted to just convert that to an equation, we know that this section here, we 0.05 times that first solution. Well, times the number of liters we would have. So we know we have 0.05x if we let x equal the number of liters of the 5% solution. It will be plus 0.20, well, 0.25y, where y would equal the number of liters of the 25% solution. Okay, and that will equal, thing is, we already know we have 10 liters of the 20% solution. That's what we're trying to get. So we don't have to put a variable there. It's just 10 times 0.20. Remember, any percentages you have to convert to decimal. So that's why the 5% became 0.05 and the 25 became 0.25. You just moved the decimal to the left twice and you just converted it to a decimal. Okay, so any questions on that setup, or hopefully it made sense? Okay, so we have our first equation. Okay, so we have 0.05x plus 0.25y equals 10 times 0.20 times 10, which you know is 2. Okay, but that really doesn't help us much because we don't have anything to go with. Well, the one thing we do know, just going from what we started off with, is that the number of liters of 5% plus the number of liters of 25% add together to give us 10 total liters. So we know that, so we know our second equation. Okay. And just like before, all we have to do is just go ahead and solve for either x or y, and then plug it into the first one, and it'd be a whole lot easier than trying to eliminate and all of that other stuff. Okay. So we can make that one 0.05x plus 0.25y equals 2, and y equals 10 minus x. See, I'm wasting all that space. I'm going to get down here and have to cram it all. Okay, so we can just go ahead and substitute that and solve for our x. Okay, let me kind of separate that a little bit. 0.05x plus 0.25, and instead of y, we just put in our 10 minus x equals 2. Okay, so all we have to do there is just solve for our x. So we get rid of the parentheses first. Plus 0.25 times 10. Whenever you get a decimal times 10, 100, 1,000, 10,000, count the number of zeros, and that's how many places you're going to move the decimal to the right. So 0.25 times 10 is 1 0, so you're going to move the decimal one place. Minus 0.25x equals 2. Oh, make sure I bring that up a little bit. Okay, and just like before, we can go ahead and combine those two. Okay, so 0.05 minus 0.25 is negative 0.20. So negative 0.20, or just 0.2, plus 2.5 equals 2. If you subtract 2.5 from both sides, okay, these two cancel out and disappear. So we end up with, oh, forgot my x, sorry about that. Negative 0.2x equals 2 minus negative, well, 2 minus 2.5 is equal to negative 0.5. Okay. So we divide both sides by 0.2, well, negative 0.2. Should bring that up enough. Okay. Anything divided by itself is just 1. So we end up with x equals negative divided by negative is positive. 0.5 divided by 0.2 is actually just 5 over 2. Which is equal to, if we do the division to convert it to a mixed number, it's 2.5. Okay, so if you get 2.5 liters of the 5% solution, now we can find out how much we'll need of the 25% solution. Uh-oh. Let's kind of separate that a little bit. So since we know that y is equal to, well, 10 minus x, okay, we know that y is equal to 10 minus 2.5. Okay, that means y is actually equal to, once you do all the subtracting of fractions, 7.5 liters. And that's how much you'll need of the 25% solution. Okay, so for most people who ask, well, where will I use this in real life? This is one of those where, depending on what you go into, you could actually use it in real life. So it's not just here to torture you. It has a purpose. Any questions on this? Okay. Let me see. I think I have one. Uh-oh. Okay. So far we've done all of our systems of linear equations in 2 variables. Now we're going to solve the ones in 3 variables. And the steps are just a little bit different.